Hello guys, good evening. Today we will be understanding some of the basic concepts in Java. We'll start with understanding the for loop and then we will be understanding the modulus operator, and along with modulus operator we will be trying to understand the use of AND operator and the OR operator. Then we will be understanding the difference between GDK and JRE, and then we will try to understand the use of scanner class. Then we will move towards understanding the sequential search, which is also known as linear search algorithm. And then we will be understanding the while loop and its implementation in Java. Then we will be understanding the binary search algorithm. And at the end, we will understand the operator precedence in Java. Okay. So guys, before we start understanding what is a for loop, we should first understand what are loops in Java. So in programming languages, loops are used to execute a set of instructions or functions repeatedly when some condition become true. Okay, so basically let's say we have some instructions that we want to execute in a repeated manner, or some functions that we want to execute repeatedly. Then we can use the loops. So one of the loop is for loop. Okay, so for loop is having a flow here. So this is the basic flow of for loop. It starts and there are three statements basically in for loop in the definition. So here the first statement is for initialization, and then the second statement is for condition. So this condition needs to be passed if the for loop needs to be executed again. So the body of the for loop, once the condition passes, the body of the for loop will get executed again. And this statement 3 is executed after the body of the for loop is executed. So this is post expression. So this is the statement 3 that increases the initialized variable by 1. So usually this is an increment or decrement statement which helps us in incrementing or decrementing the value of the variable defined in statement 1. So we can see here that statement 1 is executed only once before the execution of the code block. So this is our code block. Okay. Then statement 2 is defines the condition of executing the code block. So once this is the condition, that is statement 2, and statement 3 is the post expression here. So this post expression is always executed after the loop body. Okay. So let's try to understand the implementation. So this is a simple program in Java. Okay. Here what we have done, we have defined one array of numbers that is having 6 elements, and we have the for loop here. And as we saw in the documentation, there are 3 statements in the definition of for loop. So first is for initialization of the counter. So how many times we want to execute the statement inside the for loop body, we need to define one counter. Okay, so the counter starts mostly with 0. Okay, then you need to mention the condition which should be satisfied for successful execution of the for loop body. Okay, then at the end, after this for loop body gets executed, there is a increment step. Okay, so this is the third statement which is executed always after this statement, that is the complete for loop body. This statement is executed to increment the value of I by 1. Okay, so this starts with 0, and once this is executed, the counter increases. Okay, so we want to execute this for loop body for 6 times. Okay, that's why we are mentioning here that I, until and unless the I is less than 6. And why we have mentioned I is less than 6? Because we want to print all the values from this array. So the values in this array are 6. Okay. So that's why. And an array begins with index 0. Okay. So we can visualize one array like this. So this is an array, right? So this is an array. These are the array values and these are the array index. So the index of an array is starts with always 0. Okay, and it continues incremental. So this is 0, this is 1, 2, 3, 4, 5, 6. Okay. So here we have 7 elements, but in the code we have 6. I'll make it 7 for better understanding. Okay, so now we have same. So we will make this again 7. Okay, to match our visualization of array. Okay, so this is an array as we are visualizing this, and we have made same here. Okay, so this is an array and this is at index 0, index 1, index 2, 3, and incrementally till index 6. Okay, so the length of the array is 7, but the index count is here till 6. Okay, because it is beginning with 0. Then what it will do, this for loop, this is the array and we are fetching the values of the array using the index. So at first the value of the I will be 0. Okay, I'll start this execution in a debug mode. So now what happens at very initialization, the I is equals to 0. Then the flow control has come here to this statement. Now what will happen? This statement will get executed and this condition is already verified. So once the I is initialized to 0, this condition is verified. That is I is less than 7. That is 0 is less than 7. Okay. Now this statement will execute. Now this statement will execute. That is the value of I will increment by 1. See, the value of I got incremented by 1 and this condition again got verified. After this increment of I, the condition got verified. That is I is still less than 1 because less than 7. Okay, so 1 is less than 7. Okay, then again this statement will get executed. So see, the value 10 got printed here. Now 20 got printed because it is an index 1. Now the index will increment by 1, that is I will become 2 because this statement will get executed. So the value of I becomes 2, that is the index 2. So this is 0, 1 and this is 2. So at index 2 we have the value 30. Okay, so this is an array numbers of index 3, numbers at index 3, that is 30. Okay, so now it will print 30 here. So the current value of the array is 30. Okay, then again gradually the values will get printed until and unless the I is less than 7. Now the I is 6. Okay, so we have printed all the values because I has become 6, right? So the index is 6. That's why 70 got printed. Now what will happen? This statement will get executed, but this condition will fail because I is no more equals, no more less than 7. Now this will become equals to, that is 7 equals to 7, but this will become false because this is a less than sign, right? So now the flow of execution has come out of the for loop because this condition become false, right? So I plus plus made the value of I equals to 7, but we want I should be less than 7. So that's why the flow of execution came out of the for loop. So inside this body, you can mention the functions, the statements that you want to execute repeatedly until this condition is satisfied. Okay, so you can mention any other condition also here. So it's just a simple for loop, just for understanding purpose. Okay, now there is again a variation in for loop. So in the format of for loop, there is a variation that is called as for each loop. So we will try to understand the for each loop also. Let's go to the documentation. So there is a variation in the format of for loop that is called as for each loop. So for each loop is exclusively used to loop through the elements in an array. Okay, so what it says, so this is an array, that is array name. Okay, and this is the type of variable. Okay, so we need to define the variable of same type of array. So let's say we have an integer array, then we need to define a variable of same type here. Okay, so this is the code block and this is the definition of the for each loop. Okay, this is for each loop. Let's go to the code. Okay, so see, this is the basic implementation of for each loop. So we have the numbers array here, that is of type integer, and we have defined one variable of type integer. Okay, so basically the for each loop is another array traversing technique like for loop, while loop and do while loop. Okay, and it was introduced in Java 5. So basically it starts with the for like a normal for loop. So we don't need to initialize a loop counter variable, right? We don't need to initialize a loop counter variable here. So basically we declare a variable that is the same type as the base type of the array. So as the array is of type integer, that's why our variable was of same type integer. So and it is followed by, the variable is followed by the colon, which is then followed by the array name. Okay, and in the loop body you can use the loop variable that you created rather than using an indexed array element. Okay, so indexed array element means, let's try to see in the code. So this is our normal for loop and this is the index. Okay, I is like also behaving like an index, so this is our array and this is an index. So we don't have this format in the for each loop. Okay, we can directly use the variable here because we have defined like that. So this format means for each integer in the numbers array, get me the value. Okay, so this will get us the value. So integer will now be having the first value of the numbers. Okay, at very first point of execution. Okay, so and it's commonly used to iterate over an array for collection class. Okay, so over an array or a collection class. So collection class is basically array list or a list, right? Or you can say hash maps are also sometimes iterated through the for each loop. We can get the key set from the hash map and iterate over the key set from the for each loop. But we will understand that later, how we can use the for each loop to iterate over an array list or a list. Okay, so then we have this body that is again same, and it is equivalent to the normal form. Okay, so this and this is same. Okay, let's try to understand the implementation now. So what it will do, one by one it will get us, this implementation will get us each element of the array in this integer variable. Okay, so we don't need to define any kind of customized index here. We don't need to define the three statements that we defined in the normal for loop. Okay, so one by one this value will come here, but there are also some limitations related to the for each loop, so we can try to understand those limitations also. So the very first limitation is like for each loop are not appropriate when we want to modify the array. Okay, so as we visualize the array here, so this is our visualization of array. So let's say you want to modify the value of an array at index 2. Okay, so basically you can modify the value of an array using the index Okay, like this. So let's say we have an array and we are providing the index 2 and we want to change the value. So we will just say equals to, okay, we will just say equals to array index 2 equals to 100. Okay, so now this will make the value here 100. Okay, but this facility is not available in the for each loop in a normal manner. Okay, so see, here we don't have any index, that's why we can't change the value of an array in the for each loop manner. Okay, now let's go to the next limitation. So this is our next limitation, that is for each loop do not keep track of index, right? As we saw here, we don't have the track of index, so we cannot obtain array index using for each loop. So this means the same, so we can't obtain the array index in the for each loop, right? So let's say you want to search an element in the array. So let's see the array. So this is our array, right? This is our array, and we want to find that where the value 40 is present. The value 40 is present at index 3, but we want to find that. As of now, we don't know, the program doesn't knows that where the value would be stored. Okay, so in the for loop, in the normal for loop, we have the facility of index, right? We can simply loop through this for loop, and we would say once the numbers, we would say if the number equals to 100, or let's say now we want to find 40, then print the index. So this will print the index, that is the position where the value 40 is present. Okay, but we cannot do this kind of finding of the position in this for each loop. Okay, this is our for each loop. We don't track the index here, that's why we can't find the position where the value is present in the array. Okay, so the array is this, and in the normal for loop we have the facility to get the index where the value is present. Okay, let's go to the next limitation. So for each loop only iterates forward over the array in single steps. So for each loop iterates in a forward only manner. Okay, so it will first iterate over this first index, then it will move to next index, then next, then next, then next. Okay, accordingly it will move till the last index. So this is forward only manner, right? The for each loop can't come back because there is no tracking of index, right? So again, this is a limitation we can say, but we can iterate in a reverse manner in a normal for loop. How we can do that, we can try to understand through code. So here we have defined a for loop again, that is a normal for loop, and we have the postfix decrement of decrement statement here, right? So what will happen, we will initially initialize the counter to 5. Okay, I'll make it 6 because we have 7 elements. So basically when we have 7 elements in an array, the index starts from 0, 1, 2, 3, 4, 5, 6. So the last index is 6. That's why we have defined here 6. Okay, we have initialized the array to 6th index. So what will happen, at very first point of execution, this will print 70. Then we are checking that index 6 is greater than 0. So we are initializing first, that is I equals to 6, then 6 is greater than 0. This condition passes, this statement executes, then the control comes here, that is I minus minus. Now I will become 5 because we are doing minus minus here. So this is a decrement operator. Okay, this is a decrement operator, and earlier it was increment. So now we are decrementing. So the value of I will reduce by 1 here. Okay, so what will happen? The I will become 5. So for at fifth index, we have 60, right? So 60 will get printed. Let's try to see. The control is as of now here. I'll move to next step. Okay. So I'll stop the program again. Stick it. So control has come here, right? So what will happen at very first point? The I is having value 6. That is the index 6. That is the value 70 will get printed. Okay, the current value is 70. This got printed. Now what will happen? The control will come here. That is I minus minus. The I will become 5. So I has become 5. Now the index 5 value will get printed. That is 60. Okay. So let's see. So now current value is 60, right? 60 has been printed. So accordingly, the value of I will keep on decrementing and we are parsing the array, we are traversing the array in a reverse manner. But this functionality we can't achieve in the for each loop. Okay, this is again a limitation of for each loop. And now we will go through one more limitation, that is for each loop cannot process two decision making statements at once, right? Because we don't have the facility to mention the decision making statement here. So we have the facility to mention the decision making statement here. Right? We have the facility, that is we are making a decision here, and then once the decision is successful, then this statement gets executed. So you can mention another decision here, right? So this is I greater than 0. What we can do, we can add a AND condition, okay? Or we can do OR condition. So that is this. So we have the OR operator and the AND operator. Okay? We will say AND I is greater than 1. Okay. So now we have two decision making statements here. But this we cannot mention in the definition of for each loop. Okay? So this sysout will only get executed when the value of I is greater than 0 and the value of I is greater than 1. That is, until and unless I is 2, 3, 4, 5, 6, the value will get printed. Okay. So these were the limitations of for each loop against the normal for loop. So guys, now we will try to understand the use of modulus operator in Java. Okay. So modulus operator basically gives us the remainder. Okay. So let's say you are dividing one number with another. Let's say you are dividing 10 by 2. So it's a successful division. So the remainder at one point of time will become 0. So whenever the remainder becomes 0, we can use the modulus operator to determine such successful division. Okay, so we will try to understand how this works. Okay, so let me open. So this is the modulo operator. So the modulus operator always returns an integer. Okay, so modulus operator will always return an integer value. It will never return an float. If we try to use the modulus operator with any other type of variable, that is float or double, we will get an compilation error. So the modulus operator looks like a percentage sign. Okay. So basically, whenever we want to check whether a successful division is happening or not, that is, let's say 10 divided by 2 will never leave the remainder as 1. Okay, so it will leave the remainder as 0 because 10 divided by 2 is 5 and the remainder is 0. Okay, so that is a successful division. But when we divide 5 by 2, that will not be a successful division because 10 is pardon, 5 is not successfully divided by 2. It will leave the remainder 1. Okay, so we will try to understand that how we can use the modulus operator to get all the odd numbers between 20 to 40. Let's go to the code. So this is modulus operator implementation. Okay. So first we will try to understand how to get the odd numbers. Okay. So what we have done, we have defined a for loop here. Okay. So this is the main function, and we have the for loop initialized with value 20 because we want to find the odd numbers between 20 to 40. Okay. So this for loop will execute until and unless the value of number is less than or equals to 40. Why we have put the equals to sign? Because we want to find the odd numbers between the range of 20 to 40. So we want to go 20 to 40. Okay. So what will happen? This will get initialized first, and then this condition will get checked. That is num equals to 20. Num is less than equals to 40. 20 is less than 40. Then the flow control will come here. The execution flow control will come here. That is, this condition will be checked. That is num mod 2. So let's say initially it is 20 mod 2, and so 20 mod 2, 20 divided by 2 will be 10. So the remainder is 0. Then this is a successful execution, and this is the not sign. Okay, so 20 divided by 2 leaves 10. Okay, and the remainder is 0, and it's a successful division at the end. So this will be false because this not is there, right? So this not is making the true as false. Okay, so whenever this condition will pass, the odd number will get printed. Okay, let's start execution. So I have put a debug point here. So what has happened? At the first point, the num was 20. So this condition failed. Okay, because num mod 2 is making the remainder as 0. Hence, this was true, but we have put the not sign here, that is making true as false. Okay. So then what happened? This num got incremented, right? That is, it became 21. The value of num is now 21, and that left the remainder 1. Okay, so num mod 2 becomes false, and this not is making false to true. Okay, so now this has become true. That's why the 21 will get printed. That is, 21 is an odd number, right? And it is between the range of 20 to 40. Okay, so this gives us true or false, and this not is making the opposite. Okay, so basically once this is true, it will become false due to this not operator. Okay, so that is, this condition is being made opposite due to this not operator. Okay, so let's go to next step. Again, what happened? This num become 22. Okay, so 22 is not an odd number, that's why the execution flow will not come here. Okay, so 23 is an odd number, and num mod 2 will leave the remainder 1, and this condition was false, but this not operator has made it true. Okay, so 23 will get printed because 23 is an odd number. So all the odd numbers are being printed here. See, 21, 23, 25. Okay, so now I'm continuing till the end of the loop. So see, all the odd numbers between 20 to 40 are now printed on the console. So we have another example for modulus operator, that is, we want to find the numbers divisible by 3 between the range of 12 to 34. Okay, so numbers which are successfully divisible by 3 will leave the remainder as 0. Okay, so we have this successful condition here. Okay, I'll start the execution and I'll put the limit point on all the for loops. Okay, so what we have done in this program, we have basically declared one first number, that is 12, because we want to start from 12 and we need to end at 34. Okay, so we need to end at 34. That's why our last number is 34. Then we have defined one for loop here. Okay, so we have defined a variable, that is current number, and we are initializing it to the first number. So our current number is now first number, that is 12. Okay, then we have a condition here for loop. So current number is less than or equals to last number, that is 34. So 12 is less than 34. So this condition will pass. Okay, then the flow of execution will come here. So the current number is 12, and if current number mod 3, that is if 12 divided by 3 is a successful execution, and at the end it will leave the remainder 0. So this condition is passing, right? So the flow of execution will come here and this will get printed. So 12, it is divisible by 3 and the remainder is 0. Okay, now next is 13. So 13 is not divisible by 3. Okay, so 13 is not successfully divisible by 3. That's why this condition, that is the modulus condition, will become false. That is not equals to 0. So that's why this is false. Okay, so the 13 did not get printed here. So accordingly, all the values which are divisible by 3 and are in the range of 12 to 34, all values will get printed. Okay, I'll remove the debug thumb. So all values are now printed. So first 12 was divisible by 3, then 15, then 18, 21, 24, 27, 30, 33. Okay, our last number was 34. That's why 33 got printed at last. Okay, now we want to print all the numbers divisible by 3 and 5. So we are going to use the ampersand operator here, right? So this is a AND operator. In this manner, we are mentioning the AND sign here. Okay, ampersand ampersand means the logical AND operator here. Okay, so the numbers would be between 12 to 34. Okay, so this is our for loop. We are again declaring this variable here, it is integer current number equals to the first number, that is 12. Okay, so this is 12, and the current number is less than equals to the last number. Okay, so last number is 34 and the current number is 12, and now this will execute after the for loop body. Okay, so what we have done, we have the condition here, that is if current number, that is 12 mod 3 equals to 0. Okay, and the current number is also divisible by 5. Okay, the current number should be divisible by 3 and it should be also successfully divisible by 5, and it should not leave any remainder, and the remainder should be equals to 0. Okay, so then only the value will get printed. So the current number is 12, so the flow of execution will not come here and the 12 will not get printed. Okay, so let's see. So at 12 the value does not get printed here. Okay, see, still this statement is there. Okay, now 14 13 14 will also not get printed because they are not divisible by 3 or 5, I mean and 5. Okay, so 15 will get printed because 15 is divisible by 3 as well as 5. So let's see if 15 got printed. So current number is 14. Now current number is 15, so it will get printed. Okay, So 15 got printed successfully because 15 is successfully divisible by 3 and 5, and accordingly all the numbers divisible by 3 and 5 will get printed here. Okay. So first was 15 and the next number was 30, between the range of 12 to 34. Now what we are trying to do, we are trying to find a number divisible by 4 or 5. So either it should be divisible by 4 or it should be divisible by 5. So what will happen basically, the condition that we have inside the for loop is the number should be divisible by 4 or 5. So once this condition passes, the flow of execution will not check this condition. Okay, so this condition will only be checked if this condition is false. Okay, so this both conditions could be false and the flow will not come here. Okay, if this condition passes, then also the flow will come here because this is a OR operator. Okay, so let's see. So the current number is 12. So 12 is divisible by 4. Successfully divisible by 4. That's why 12 will get printed. And now the number is 13. 13 is not divisible by 4 or 5. That's why this condition will fail. Then again 14 is also not divisible by 4 or 5. That's why this will fail. Now 15 has come. 15 is not divisible by 4, but it is divisible by 5. Okay, so that's why the 15 will get printed now. Okay, so first the 12 got printed and then 15 got printed in. Now the next number would be 16. Okay, 16 will also get printed because it is divisible by 4. So 16 got printed. Okay, accordingly all the numbers divisible by 4 or 5 will get printed between the range of 12 to 34. So I'll remove the debug point. So after 16 we have 20, 24 and 25 because it is divisible by 5 and this is divisible by 4. Okay. So till 32 all the values got printed between 12 to 34. So this was modulus operator. Okay. Now we try to understand the modulus operator and the AND operator and OR operator. Now we will be understanding the difference between JDK and JRE in Java. Okay, let's go to the documentation. So basically this is the outline for Java runtime environment. So basically JDK consists of JRE plus the development tools. Okay, and the JRE consists of the JVM plus libraries. Those are the class libraries. So basically the helper functions, that utilities, those are by default we are getting while writing the code are present in the class libraries, and those class libraries are present in JRE. So there is a concept called platform independent programming language. So many times you might have heard that Java is a platform independent programming language. But what does platform independence means? Okay, so platform independent means the program of that particular programming language will get executed on any platform, that is operating system. So the Java program is capable of getting executed on Windows machine, on Linux machine, on Mac OS. Okay, why? Because the JRE is present on Windows, Linux, and Mac OS. So without JRE, that is Java runtime environment, the Java program will not get executed. Okay, so Java is platform independent because JRE could be installed on Windows, Mac OS, as well as Linux. Okay, that's why Java is called as platform independent language. Okay, then what is JDK? So JDK basically consists of Java runtime environment as well as development tools. So if you want to write a Java program, then you need JDK. But if you want to just execute the Java program, then you just need the Java runtime environment. Okay. For writing a Java program, you need JDK. But if you want to just execute the program, then you don't need the JDK. Okay. JDK is heavier than Java runtime environment. Okay, because that contains the development tool also. So basically, if you see, there are some small machines where the Java program is running. Okay, like small machine could be your home appliances. Okay, so there also Java is installed in nowadays. So that doesn't need this JDK, okay, because there the program we don't write the program in the home appliance, but still the Java is installed in that particular home appliance. Okay, so so Java development kit is which provides the environment to develop and execute the Java program. JDK is basically a kit, okay. So development tools to provide an environment to develop your Java programs, and Java runtime environment is to execute your Java program. Okay, so we will try to understand now what is JVM. So Java Virtual Machine is an important part of both JDK and GRE because it is contained or inbuilt in both. Okay, whatever Java program you run using GRE or JDK goes into the JVM. Okay, JVM is responsible for executing the Java program line by line. Hence, it is also known as interpreter. So there are some parts inside the Java which are known as interpreter, compiler. Okay, so those are very low level parts, but you don't need to worry about those concepts at a higher level when you are writing the code. So it's just a concept that you should sometime try to understand the concept of interpreter in programming language. Okay, so basically this was difference between JDK and GRE. That is, JDK is basically responsible for providing you the tools for developing a software, and Java runtime environment helps you in executing the Java program that you have written using JDK. Okay, so let's go to the next point now. The next point is the use of scanner class. So basically scanner class helps us in getting the input from the console window. Okay. So guys, now we will try to understand what is scanner class in Java. So sometimes we need to take the input from user from the console window. So we can use the scanner class in Java. Okay. And the scanner class in Java resides in the java.util package. So there are various packages in Java which we can use to achieve a particular task, and those packages are kind of helper packages which contain the helper classes. Okay, so as we can go through this paragraph, that the scanner class is used to get the user input and it is found in the java.util package. And to use the scanner class, we need to create an object of the scanner class and use any of the available methods found in the scanner class documentation. Okay, so you can go to the documentation of scanner class and use and go through the various methods available in the scanner class. So we will take one example here. We will be using the next line method, which is used to read the strings from the console window. Okay, so we'll now go to the code and try to understand how we can use the next line method from the scanner class. So this is our Java program, which we will be using to understand the scanner class in Java. So what we have done in this program is basically we have declared two variables. Those are integer variables, the first and last, and simply we are creating an object of scanner class. So input is the object of scanner class. Okay, we can go to the definition of this class also. As you can see, the java.util package contains, and this is a final class, so no other class can extend the scanner class. Okay, and the scanner class extends the object. Okay, so a simple text scanner which can parse the primitive types and strings using the regular expression. So basically it's a helper class to parse the input from the console. Okay, and we have created the object here. So, and in the constructor, so this is the constructor of scanner class, and we need to provide the system dot in. So what is system dot in? So system dot in is basically the input stream. Okay, so public static final java dot io dot input stream. So this is system dot input stream. Okay, so we need to provide an input stream object here, right? So directly we are providing the input stream in the scanner class constructor. Okay, so then in the first variable we are collecting the input from user from the console. So this is integer class. Okay, we are converting. So when we say input dot next line, so it basically gets us the input in a string format. So somehow we need to convert the string received from the console in the integer format. Okay, so this is the way how you can convert the string to integer. So we are using the integer class, and value of is a static method. Okay, so you can see public static integer value of. So the integer will return the object of, so the value of method will return the object of integer class. Okay, and we need to provide the string as an input to this method. So input dot next time will get us the string input, and we are converting string to integer. And again in the same manner we have the last variable where we are receiving again the input from user from the console window. So input dot next line. Okay, so then we need to close the input stream, right? So we have received the input successfully. Now we need to close the input stream. We have provided the input stream here and created the scanner class object. Then we need to call the close method to close the input stream, right? Closes the scanner. Okay, so then we are printing the first and last variable. So I'll just simply execute this program in a debug format. Okay, so now what has happened, these two variables are initialized to 0. Okay, now we will one by one go through the steps of this program. Okay, so the scanner class input object is created now, and then the command prompt window is waiting for us to enter some value. Okay, because we have executed this line of code. Now we will enter 20, and then the flow of execution goes here, okay, to the last variable. So again the command prompt window will be waiting for us to enter some value. So we will enter. Okay, now we need to close the input object that is of scanner class. Okay, so now it will print the first variable. So the first number entered is 20. So what happened, we are simply printing the first variable value here. Okay, then we'll again print the last variable value, and successfully the value has been printed. So we entered 20 and 30 and successfully it has been printed on the console window. Okay, so guys, now we are taking another example on the scanner class topic. So this is the basic Java program where we will be adding the values of two arrays, and then those values will be stored in the third array. Okay, so this is basically one array which is of length 3, and this is another array of same length, that is the length 3. Okay, the length of this array we will be defining later. Okay, so now to take the input from the console, we have defined a for loop here. Okay, because we want to take the input in a repeated manner 3 times. So that's why we are using the for loop. Okay, so in this for loop, we are taking the input for first array. So here we have the sysout, and then we are creating an object of scanner class. Okay, and we are providing the system.input stream in this object, that is my obj, and this is the constructor of the scanner class. And then we are storing the value received from the console in this array variable. Okay, so this is the array 1 and this is the index, and we are accessing that particular variable in the array. Okay, so this array is of type integer and it will store 3 values. Then again we have a for loop for getting the input from the console and storing the values in the second array. Okay, then here we have one condition to define the length of the third array. Okay, we are adding a condition, that is array dot length equals to array 2 dot length. Okay, so we are making sure that the two arrays are of same length and then only define the length of third array. Okay, so here the length of third array again becomes 3 because the array 1 length and the array 2 length is same, that is of length 3, and this will be same length. Okay, so why we have made this of same length? Because we want to store the same number of elements, those are stored in the array 1 and array 2. That's why it's of length 3. Okay, now we have another for loop here where we are simply storing the addition of two arrays. We are doing the addition of values of two arrays by accessing the values through the index, and we are using the same index to store the values in the third array. And then we have another for loop to print the values. We can combine these two for loops basically, but just for simplicity purpose, we have defined another for loop. Okay, and then if in any case the length of the array 1 and array 2 is not same, then we will be printing the array 1 and array 2 length is not matching. Okay, and this process will not take place. Okay, so this is the scope of if. Okay, you can see this is highlighted and this is the scope of this if condition. Okay, I'll simply now trigger the execution of this program in the debug manner. Okay, so now what has happened, this for loop execution has been started and the I is initialized to 0 because this is the very initial definition of this variable I. Okay, so now we have created the object of scanner class and then we have the array 1 of I. So array 1 of I means this first position. Okay, so we have taken the, now the console is waiting for us to enter some value. So now we will enter the value here and then the flow of execution again goes to the this condition check. Okay, so still the length of the array is 3 and the I value is 1 because at the initial phase it was 0. Now due to this I plus plus, the value of I becomes 1. Okay, so now the value of I has become 1 and now we will be entering the another value in the array. Okay, so this is 20. Again we will do the same thing, we will enter the third value and the final value of the array. Okay, now we are in the second for loop, that's why it is asking enter the value of second array. Okay, so now we will enter the value of second array, that is 40, and then again it has asked, it will ask 3 times because the length of the array is 3, and now we will say 60. Okay, now we have entered the values in both the arrays. Now what will happen, we will be in this if condition and we will be defining the length of the third array. Okay, so the length of third array is 3. Okay, and we are now adding the values of two arrays and storing them in the third array. Okay, so what has been done, the two arrays values were 10, 40, 20, 50 and 30, 60. So this has been added and stored in the third array. So 10 plus 40 equals to 50 and 20 plus 50 equals to 70 and 30 and 60 is 90. Okay, so successfully the addition has been done and now we will be printing the values. So the values has been print here. Okay, so first 50 got printed. Okay, and then 70. Now 90 will get printed. Okay, so successfully the values have been printed here. Okay, so this is how you can get the input from the console and perform addition of two arrays and store the values in the third array. Okay, so this was another example on the scanner class. So now guys, we will be understanding the implementation of sequential search algorithm. So what is sequential search? Basically, sometimes we need to find a particular value in an array, and that is called as a search technique. Okay, so we are searching something in an array and we want to get the position also where the particular value is stored in the array and is the value present in the array. Okay, so these two things we want to check. Okay, then we can use the sequential search algorithm. So we can try to visualize one array like this. Okay, so this is an array and these are the values of the array. Okay, this is a sorted array, and sequential search works on both sorted array as well as unsorted array. So sequential search will also work in this manner. Okay, so let's say this is 100 and this is 5 and this is 20 again. Okay, so this is an unsorted array. Okay, sequential search will work on this. So basically sequential search searches the value sequentially. Okay, sequential search searches the value sequentially one by one with the help of for loop. The sequential search traverses through the array and the value is compared with the specific value that we need to find. So let's say we need to find a value called 60, okay, which is present at the fifth location. Okay, the value 60 is present at fifth location of the array. So what sequential search will do, it will one by one compare the current value, that is, let's say this is the current value and that is 100 at index 0. So this will compare the value with 60. Okay, so is 60 equals to 100? No, then it will move to next value, that is 5. Okay, so it basically traverses with the help of index. Okay, first it will be 0, then 1, 2, 3, 4, 5, 6. Okay, so sequentially it will go through one by one through all the indexes and fetch the value of the array. Okay, and compare with 60, and once the value is found, so it will return the index and update the is found flag to true. Okay, so we have some documentation for this also. Okay, so this is linear search, and a simple approach is to do linear search, that is start from leftmost element, that is 0th index of array, and one by one compare x with each element of the array. So x is the value to be found. Okay, x is our value to be found, that is 20 here. Okay, so one by one compare with each element of the array. So these are the elements of the arrays. Okay, if x matches with an element, return the index. If x does not match with any elements of the array, then return -1. So sequential search is a very simple search technique, and this is a very simple algorithm, and it may come up in the interview questions. Okay, so you can simply implement this with the help of single for loop. Okay, let's go to the code now. So this is the implementation for sequential search. Here in this simple Java program, what we are doing, we are initializing one array here. We are defining one array here, and we want to find some value called as 40. Let's say x equals to 40, and we have defined one is found flag. So this is Boolean data type, and Boolean data type has two values only. Two possible values are true and false. Okay, integer can have integer type values and boolean will have boolean type values, that is true and false. Okay, so integer can be 1 2 3 4 5 6 7 8 like this, but here the values are only 2, that is true and false. Okay, so we have by default given the false value to the is found boolean variable. Okay, then we have defined one search result index. variable which is by default having the value -1, because the computer doesn't knows that is the value to be found is really present in the array or not. Okay, so basically by default we will assume that the value is not present, but once the value is found we will update the value, that is the index here, that is the search result index, we will be updating inside the for loop. Okay, so now we have defined another variable where we are storing the length of the array. So array dot length, this will give us the length of the array, which is basically 6. Okay, because we are having 6 elements in this array. Okay, so now n will become 6. Now we have one for loop here where the implementation of sequential search is basically present. Okay, so we will iterate through each and every element of the array. We have the first statement as the initialization of for loop to I equals to 0. So I is our index counter. Okay, so until and unless I is less than n, that is I is less than 6. Okay, the I will be plus plus. Okay, so the counter will get incremented by 1. This is the increment operator. Okay, so here we have a condition where we are checking the value, the current value that is fetched from the array is equals to x or not. Okay, so once this condition becomes true, then this scope will get executed. These three statements will get executed. So what we are doing, we are updating the search result index where the value is found in the array. Okay, so the position where the value is found, so the value is present at 0 1 2 3 4. So this is fourth index. At fourth index the value is present, so the search result index should become 4, and this is found flag is set to true. Okay, is found flag is basically a boolean value which will be set to true if the expected value is found in this array. Okay, and then we will break. So break simply gets us out of the array. Okay, so when you are executing a for loop, so you might be imagining that all the values will be checked. Okay, the for loop will be executed 6 times. The body of the for loop will get executed 6 times, but if we want to forcefully break the for loop, then we can use this break statement. Okay, so this will get us out of the for loop, and basically the flow of execution will come here. So there is another statement called as continue. We'll try to understand that later, but as of now we can focus on this break statement, which simply gets us out of the scope of this for loop. Okay, then what we are checking here is if the search result index equals to -1, that is the case when the element is not present in the array. Okay, and if the is found flag is equals to true, we are having an else if condition here. So if the element is found and we are checking the is found flag is set to true, then print element is present at index, that is the search result index. Okay, the search result index would be 4 because we are searching for 40. Okay, so now I will execute this program in a debug manner. So what has happened now, the flow of execution has come to this statement where we are setting the length of the array, that is n is equals to array dot length. Okay, so it will be 6. So the value of n has now 6. Okay, then we are going into the for loop. So at the first iteration the I will be 0. Okay, and this condition is checked, that is 0 is less than 6, and that is true. So that's why the flow of execution has come here. Okay, so now if array of I, that is array of index, the value at index 0 is equals to x, so x is 40. So at first index we don't have 40, so this condition will become false. Okay, so now this is false, then again the iteration will increment the value of I. Now the value of I has become 1 and still I is less than 6, so that's why this will execute again. Okay, now again the condition is checked, that is the value present at index 2, that is 3, is equals to 40. So that's it, that is also false. So this again will continue and the flow of execution will come here. Okay, until and unless the value of array of I becomes equals to 40, the flow of execution will keep on continuing, and it will continue only till 6 iterations. Okay, until and unless the value of I is less than n. Okay, so now we are at index 4 and the value at present at index 4 is 40. So this should pass now. Okay, so see, this has been passed because the value present at index 4 was 40. So array of I is 40 and equals to x, that is 40. Okay, so now the search result index will be updated to 4. So the search result index has become 4. Okay, and the is found flag will be set to true. And as we have mentioned the break statement here, so forcefully the scope of execution will be broken here, and the scope of the flow of execution will come out of the for loop. Okay, so see, the flow of execution has come out of the for loop, and now it is being checked that search result index equals to -1, which is false. So we will bypass this condition, and then again else if is found equals to true, which is true. So this sys out will get executed. Okay, so the element is present at index 4. Successfully we have found the value. So if you will not mention this break statement here, all the 6 iterations will happen and even 100 will get compared to 40. Okay, now what happened? We executed the loop only 5 times. Okay, it was expected to be executed to 6 times, but due to break statement, it executed only 5 times, and this is called as efficiency of the program. So we have improved the efficiency of program by forcefully reducing one step of execution for loop. Okay, so now what we'll do, we'll change the value to be found to the value which is not present in the array. So it will be 103. So 103 is not present in this array, and what will happen, finally the flow of execution will come to this statement. Okay, because this for loop will not be able to find the value 103 in the array because it is not present. Okay, so I'll debug the program again. Okay, okay, the flow of execution has come here, that is int n equals to array dot length. Now the value of n is set to 6. Okay, now we will, this for loop will iterate till 6. Okay, until and unless the I is less than 6. Okay, so every time the value from one value from the array is being compared with 103, and this condition is consistently false. Okay, see, now all the iterations has been completed, the value of I has become 5 now. Okay, so 5 and then 6. Okay, the value of I becomes 6, and this for loop got completed, but the value that we were expecting is not found in the array. Okay, this condition failed every time, and now the flow of execution will go here because the search result index value is not updated, because the flow of execution doesn't go here anytime. Okay, so still the by default the value is -1. Okay, so element is not present in the array. Okay, so this message got printed successfully. So this is called as sequential search algorithm, and it is very simple algorithm, and you can just prepare a program like this in the interview questions. Okay.